Welcome, this is Samm. Today we want to solve a problem involving logarithms. So if you have not subscribed to the channel, kindly subscribe now. Let's go. So the question says x raised to power log x equals to x cubed over 100. So we have to solve the equation. Okay, we can consider bringing this log down using this law that says log a raised to power b equals to b log a. So applying this law, we can go with this. So if we add log to both sides, so I'm adding log to both sides now, equals to log x cubed over 100. So following this now, we'll have log x equal to, okay, we can do something here. If you remember the quotient law of logarithm, log a over b can be written as log a minus log b. So applying this here, we'll have log x cubed minus log 100. Okay? Now, when the log is not written, it is 10. So what we have is like log 10, 100. So we can look at that. So here we have log x equal to, okay, applying this same law, this will give us 3 log x, yes, minus log 10 squared. So log x can be written as log x all square, just like p times p is p squared. So log x times log x is log x squared equal to 3 log x minus 2 log 10. And remember, log 10 with a 10 down here is 1. So this will give us log x all squared equal to 3 log x minus 2. 2 times 1, this one here will give us 1. So 2 times 1 is 2. Okay, so this is looking a bit quadratic. So we can do something from here. Log x all squared minus 3 log x minus 2 comes here, becomes plus 2 equal to 0. So from here we can say let log x equal p. So since we have log x and log x here, let it be p. So by implication, we'll have p squared, that's log x squared, minus 3p, which is log x, plus 2 equal to 0. So this is a quadratic equation. So we can factorize it easily. Remember, the first term multiplied by the first term gives us this first term, so which is obviously p and p. So p times p is p squared. Now the last term multiplied by the last term will give us this last term 2, which is obviously 1 and 2. So 1 times 2 will give us 2. Now the question is how we get our negative 3. Now, if you multiply these outer items, you have 2p. That's outer items. 2 times p is 2p. If you multiply the inner items, 1 times p is 2. So minus and minus will give us minus 3p. minus 3p. So minus and minus are required to give us minus 3p. So minus and minus. I believe you understand. So let's proceed. So when you have a product equal to 0, it is either p minus 1 equals 0 or p minus 2 equal to 0. And this gives us p equal to 1 or p equal to 2. Yes, so we've gotten our answer for p. But originally, we had to look for x. Now let's compare this relation with this. So when p equal 1, let's start from this. When p is equal to 1, remember that p is equal to log x. That means log x equal to 1. Remember our law when converting from logarithm to indices. Let me bring it here. If you have log a equal to m, which has a base b, the number of the log a will be equal to the base b raised to power m. So this is how we convert from logarithm to indices. The number of the log stays, the base comes this way and raises the number here m up. So this gives this. So now we can apply the same thing here. So remember I said this has 10 when it's not written. So, sorry, x, now the number will be equal to 10 raised to power 1, which is equal to 10. So when p is 1, x is 10. All right, so what happens when p is 2, the other case? When p equals to 2, we'll have our log x equal to 2. Remember, we have a 10 here. So x, the number of the log, will be equal to what? 10 raised to power 2, which is equal to 100. So and I think that's the solution to the problem. So x is equal to 10. X is either 10 or x equal to 100. And that's the solution to this interesting logarithm problem. Now, if you have not subscribed to our channel, kindly subscribe now so you can get interesting solutions to mathematical problems. See you in the next video.